Now we are going to work on a complete confidence interval example. And so if we read through the example, we can start to gather all of the information. So we see that 800 students were selected from a population of 20,000 students. So 800 is our sample size, while 20,000 is our population size. We're not actually going to need that 20,000, but it's interesting to have. So all 800 of these students were given a flu shot. All 800 of them were exposed to the flu, and 600 did not get the flu. And so here, it tells us that P is going to represent the probability that the shot is successful. In other words, P represents the probability that a student does not get the flu, while Q is somebody does get the flu. A failure here is getting the flu. And so we can see that N is equal to 800. 600 did not get the flu, so that's how many successes that we have. And so when we find the point estimates for P hat and Q hat, well, we know P hat is equal to X over N. So 600 divided by 800, which is just 6 over 8, or 3 over 4, or 0.75. So 75% of the sample did not get the flu after getting the flu shot, while 25% of the sample did get the flu. Now that we have P hat and Q hat, we can use them to check and make sure that the requirements are satisfied. And so if we move on to part B, the first requirement is checking that the sample is random. And so here, if I scroll back up, it says, suppose that these students were selected at random, so I know that this one is satisfied. If I look at the second requirement is to make sure that the P hat distribution is normal. And remember, we do this by checking that N times P hat is greater than or equal to 10, and N times Q hat is greater than or equal to 10. N times P hat in this case is 600, which is definitely greater than or equal to 10, while N times Q hat is 200, and again is greater than 10. So here we can say yes, the requirements are met. So now we can actually move on to finding the confidence interval. If we're going to find the confidence interval by hand, there's a few things that we need to do first. So our confidence interval is going to be given by the values P hat minus E and P hat plus E, where E represents the margin of error. And when you're constructing confidence intervals for proportions, the margin of error is equal to this Z sub C, that critical value, times the square root of P hat times Q hat over N. So that whole fraction is underneath that square root. So that means that we first need to find our critical value. So if I bring up that applet again, and I move these lines until I have 0.99 underneath my curve, or approximately, let's see how close I can get. That's pretty close. And so I see that my critical value is now 2.586. I'm going to round that to 2.59. I think typically the one people use when it comes to a 99% confidence interval is actually 2.58. But again, this would just be a rounding issue. And so here Z sub C is 2.59, and so you have that E is equal to 2.59 times the square root of 0.25 times 0.75 over our sample size of 800. And when you enter this into your calculator, you should get a margin of error of 0.03965. And so I will say that that is approximately equal to 0.04. And so now I can actually go back up and find the confidence interval. So first I will find p hat minus e. And we found p hat in the beginning. It was 0.75. So 0.75 minus our margin of error. And so this is going to give us 0.71. And then we have p hat plus e, which is equal to 0.75 plus 0.04. And this is 0.79. So our confidence interval ranges from 0.71 to 0.79. To interpret this, we would start out by saying we are 99% confident that between 71% and 79% of the 20,000 students will not get the flu. And so it's very important that somewhere in your interpretation you are making note of the fact that you're estimating this for the population and not the sample. And so somewhere in your interpretation, make sure to include the word all, the population size, or something about the population, so that it's very clear that you understand what you are interpreting and what you're estimating. To solve this example on your calculator, there's a function that you can use that will give you this interval. And if you go to stat and then tests, there's a function called 1propzint. You may have to scroll down to find it. It is going to ask for several variables, and so the first variable you need to give it is that value of x, the number of successes. And so in this case, you have an x value of 600. The next variable it asks for is n, which is 800, and then the last one it asks for is your confidence level. And so make sure that when you put this in, you put it in as a decimal. And then you just hit calculate, and it will give you the confidence interval 0.71057 to 0.78943. And so if you compare the two confidence intervals that we found, the one by hand and then the one using the calculator, they're exactly the same. If you are using this calculator or this calculator function, then you'll notice that it also gives you the value of p hat, which is the same value that we calculated in the first step.